All right, continuing on factoring trinomials where a is greater than 1. Last lesson where we had a is greater than 1, there was no GCF for us to take out. But if we look at example 1, 14x squared minus 26x minus 4, I can tell that there's definitely a number that goes into all three of these numbers. But a way to check is to start with the lowest number. So if I look at my numbers, 4 is the lowest. I try to see if 4 can divide into 4 and 26, but 4 cannot divide into 14 and 26 evenly. So then I would break down 4 and think of the next multiple or next highest multiple of 4 that breaks down to it. And the only way that 4 breaks down is to 2 and 2. So if I double check these numbers with 2, 4 definitely divides by 2 because it's a multiple of 4. 26 is divisible by 2 evenly, and so is 14. So our GCF now is going to be 2, and we're going to divide each term by 2. So 2 on the outside. 14 divided by 2 is 7x squared. Negative 26 divided by 2 is negative 13x. And negative 4 divided by 2 is negative 2. Double make sure that that's a 13. Okay. So now we continue the process just like we always have. We are going to write 2 out in front of our final answer. So we're going to make our x, a times c above, b below. I'll label my a, b, and c this time. A equals 7, b equals negative 13, and c equals negative 2. Multiply 7 times negative 2, which is negative 14. B is negative 13. Multiples of 14 are 1 and 14, 2 and 7. Since AC is negative, I'm looking to subtract the 13. So if I look, 14 minus 1, there it is, because that does equal 13. Since 13 is negative, I need it to be, the negative to be with the bigger number. Double check our x. 1 times negative 14 is negative 14. 1 minus 14 is negative 13. So let's go ahead and divide our side numbers by a, because if you guys notice, our a is no longer 1, it is 7. So let's go ahead and do this. 1 divide by 7, which does not reduce. It would just stay 1 over 7. And then we would have negative 14 divide by 7, which reduces to negative 2. Writing our binomials out. The bottom number is our leading coefficient in the binomial, so this would be 7x. It's positive, so plus 1. And our second one, there is no denominator, so it's 1, or just x negative 2, so minus 2. And then bring down the 2. And there's your answer. Okay? If you want to, feel free, multiply this in the area model, and then multiply that answer by 2. Or you could distribute this 2 to the first binomial, and then make the area model after that one to check your answer. So let's do another example together. Example 2. Let's do, because we really haven't done any where we have a negative a out in front, and there's an important thing we need to talk about if we see this. So negative 6x squared minus 25x minus 25. Always, to see if I have a GCF, look at the smallest number, which is 6. 6 does not divide evenly into 25 and 25. So I would break 6 into multiples, which would just be 3 and 2, and 3 is the highest one, so I'll check it first. 25 is not divisible by 3, so I can skip it, go to 2. 2 is not even divisible into these either. So there isn't an actual integer that I can take out besides a number that is divisible by all of them, which is 1. The reason why I want to factor out 1 and not just 1 is because I have a negative a. Having a negative a, we want to get rid of that and factor out a negative 1. So we're going to factor out negative 1 so that our a can become positive, and anytime we divide by negative 1 or multiply by negative 1, all of our signs flip because that's what we're taking out. So I'll show you guys that. Negative 6 divided by negative 1 is positive 6x squared. So again, just a change of signs. Negative 25 divided by negative 1 is positive 25x. Again, switch the sign. And again, switch the sign. So our numbers didn't really become smaller, but they did become positive. And the only time I want to do that is if the a is negative. So let's make our x. A times c, b below. A is 6, and c is 25. So we do have to multiply that, or think about quarters. If I have 6 quarters, how much do I have? I have $1.50. So 6 times 25 is 150. Relate it to money if you need to see it. And our b is 25. This one is a pretty large number. It's going to have quite a few multiples. We are still going to list them out because I don't expect you guys to be able to just think, what are the multiples of 150 that add to 25? So let's start with 1 and 50. Sorry, 1 and 150. 150 divided by 2 is 75. 3 divides evenly into it, be 3 times 50. Then we would have 4 times 32. Then we would have 5 times 30. 6. And 25, which we already multiplied together to get this. Divide it by 7, it does not divide evenly. Divide it by 8, it does not divide evenly. Divide it by 9, it does not. But we should know that it ends in a 0, so it's divisible by 10 and 15. 10 times 15 is 150. Lots of multiples to look at, but I'm looking, since it's positive, to add to 25. Way too large, that's 151, 77, way too large. So I need them to be closer in number. If I look here, that's 31, so getting closer, but 10 and 15 is 25. Okay, so we have 10 and 15 as our side numbers. Double check our signs, but they're all positive, so it should work out. 10 times 15 is 150, and 10 plus 15 is 25. We need to take our side numbers and divide them by 6. So 10 divided by 6 and reduce it. They're both divisible by 2, so this reduces to 5 over 3. And then we still need to do 15 divided by 6. And if I look at both of these numbers, they're both divisible by 3, which reduces to 5 over 2. Writing our answer, this binomial will change to the leading coefficient of 3, so 3x. It's positive, so plus, and then our top number, 5. This one, leading coefficient would be 2x. It's positive, and 5. The only thing is we factored out a negative 1 from the very beginning, so that needs to be added to our final answer. So even with large numbers, we should be able to struggle through it a little bit maybe. Use your calculator if you need to, and to find multiples, divide that number by each number if you need to, just like the process we did of that one. Okay? So let's go ahead and let you guys practice one. So let's do 15x squared minus 27x minus 6. Go ahead and pause the video so you can work on it for a few minutes. Anytime we are factoring, we want to check for a GCF. So look at the smallest number. This will make the process a lot faster, which is 6. 6 doesn't divide into 15, so I automatically know I need to break down 6. The next highest multiple of 6 is 3. And if I look, 15 is divisible by 3, and so is 27. So let's go ahead and divide all those numbers by 3. I get 5x squared minus 9x minus 2. 15 divided by 3 is 5, 27 divided by 3 is 9, and 6 divided by 3 is 2, keeping the signs. Our new a is 5, our b is negative 9, and our c is negative 2. So we would make our x a times c, b below. 5 times negative 2 is negative 10. My b is negative 9. Need to list my multiples of 10, which are 1 and 10, and 2 and 5. It's negative, so I'm subtracting to 9. That would be 1 and 10. And since my 9 is negative, I need my bigger number to be negative, which would be 10. Double check. 1 times negative 10 is negative 10. 1 minus 10 is negative 9. Go ahead and take your side numbers and divide it by your a, which is 5. So it'd be 1 over 5, which we know that does not reduce. It should still be 1 over 5. And then negative 10 over 5, which is negative 2. Rewrite these as binomials. This first one, my leading coefficient is 5, so it'd be 5x. It is a positive fraction, so the 1 should be plus 1. This one no longer has a denominator, so we know that is x minus 2. Reminder, carry down the 3 that we factored out. And there should have been your final answer. Okay, and if you mess up on that one, that's fine, because we're going to do one more practice one for you guys to try and be able to check with the video. So with number 2, let's go 16x squared plus 60x minus 100. Go ahead and work on this one, pause it, and we'll continue it here in a little bit. Should have started with the lowest number, which is 16. See if these numbers are divisible by 16, which neither one of them divide evenly. So then I need to break down 16 and think of the next highest number that divides into it, which I know that 2 times 8 is 16, so I would check these numbers with 8. Neither one of them are divisible by 8, definitely not 100. And then we would break it down again, and the next highest multiple of 16 would be 4, because 4 times 4 is 16. 2, yes, is divisible into all of them, but it's not the greatest common factor. So we're going to factor out 4 from all of these numbers. 16 divided by 4 is 4x squared. 60 divided by 4 is 15x. And negative 100 divided by 4 is negative 25. Okay. A is 4, B is 15, C is negative 25. Make our x, A times C, B below. 4 times negative 25 is negative 100. B is 15. Multiples of 100, 1 and 100. And again, if you need to, grab a calculator and start dividing 100 by the next numbers. So 100 divided by 2 is 50. So it'll be 2 and 50. 3 does not divide evenly. 4 does. 4 times 25. Divide by 5, definitely. 5 times 20. Divide by 6, no. Divide by 7, no. Divide by 8, no. Divide by 9, no. 100 divided by 10, there we go. 10 times 10 because it's a perfect square. All right. So it's a negative 100. I'm subtracting to 15. And if I look through here, the only ones that subtract to 15 are 20 and 5. So I would have 5 and 20. 15 is positive, so I know my bigger number needs to be positive, making this a negative 5. Double check. Negative 5 times 20 is negative 100. Negative 5 plus 20 is positive 15. So we're ready to divide by our a, which is 4. So we would have negative 5 divided by 4, which does not reduce. Just rewrite it to make sure that we check to see if it can be reduced. Then we would have 20 divided by 4, which is 5. Rewrite our answer as binomials. Leading coefficient for x, it is a negative fraction, so it's minus 5. Positive, so this would become x plus 5. And bring down the 4. Final answer. All right, now you should be good to go and practice more of these problems.